Now the second problem that we discussed today was appeared in year 2017. The number of the question is 6b, and the question is that consider the following: security X and security Y. Expected return relating to security X is 20%, expected return relating to security Y is 35%, variance associated with security X is 9%, variance associated with security Y is 16%, and covariance between security X and security Y is given as 7.2. Now, in the light of the Markovitch diversification principle, advise whether a risk-averse investors will have any diversification advantage in forming a portfolio of the above two securities. In the case you recommend portfolio formulation, then also determine the minimum variance portfolio combination and the risk and return profile of such combination. That means first we have to ascertain whether there will be any diversification benefit that can be attained by the investors by constructing a portfolio with security X and security Y as per the Markovitch diversification principle. If there is any diversification benefit, then we have to calculate the weight, the appropriate weight that is to be taken for security X and security Y, which will minimize the portfolio risk to the maximum extent. And after ascertaining the weight of both these securities, we have to calculate the expected return that is to be generated from portfolio and the associated risk with the portfolio by applying such weight. Now, here covariance is given in the question. Covariance between security X and security Y are also given in the question. It is 7.2, and variance relating to security X is 9%. That means here sigma X, that means risk associated with security X, will be root over of variance, that means root over of 9 equal to 3%. Risk associated with security Y, that means sigma Y, is root over of variance, that means root 16 equal to 4%. So risk associated with security X is 3%, risk associated with security Y is 4%, and we know that the formula for determination of correlation coefficient between the two securities is Rxy equal to cob xy divided by sigma x into sigma y. Here cob xy is 7.2, that is given in the question, and sigma x and sigma y are also given, and by putting all these value we have Rxy equal to 0.6. We know that correlation coefficient measure the risk in relative term. Here if we jointly hold both the security, then we have the risk of 7.2%, but if we hold security X and security Y individual, then we have the risk of 3 into 4, that means 12. So here the proportion comes to 7.2 divided by 12, that means 0.6. So here the correlation coefficient between security X and security Y, which measure the risk of holding two security together in relative term, comes to 0.6, which explain that if security X, if the return of security X increase by 1%, then the return of security Y will also increase and it will increase by 0.6%. So here security X and security Y are positively correlated, but they are not perfectly positively correlated, and here the correlation coefficient varies from 0 to 1, and when we know that when the correlation coefficient between the securities varies from 0 to 1, we have to test threshold condition. If threshold condition is satisfied, then there will be diversification benefit by constructing portfolio with security X and security Y. But if the threshold condition is not satisfied, then there will be no diversification benefit. Now here the threshold condition is Rxy less than lower sigma by higher sigma. Here in the left hand side we have Rxy, which is 0.6. In the right hand side we have lower sigma by higher sigma. Here lower sigma, that means here sigma x is 3%, sigma y is 4%. So lower sigma is sigma x and higher sigma is sigma y. So in the right hand side we have lower sigma by higher sigma, that means sigma x by sigma y, which comes to 0.75. So here left hand side become less than right hand side, and since left hand side become less than right hand side, here the threshold condition is satisfied. And whenever threshold condition is satisfied, then there will be diversification benefit by constructing portfolio with security X and security Y. Now, since there is diversification benefit by constructing the portfolio with security X and security Y, now we have to calculate the weight that is associated with security X and security Y, which would minimize the portfolio risk. And for calculating the weight that is to be taken for security X and security Y, here we have to apply the technique of differentiation on the variance function of the portfolio. We know that the variance of the portfolio is to be calculated by applying formula wx square into sigma x square plus wy square into sigma y square plus 2wx into sigma x into wy into sigma y into rxy. Now here in the formula of that variance function, there are two variables, wx and wy. Here sigma x is given in the question, sigma y are also given in the question, rxy are also given in the question. They are the constant term, but variable factors in this variance function are wx and wy. Again, we know that since it is a two asset portfolio, here wx plus wy equal to 1. So wy is equal to 1 minus wx. Here if we replace wy with 1 minus wx, and if we put the value of rxy equal to 0.6, then the formula of the variance, the function of the variance will rearranged as wx square into sigma x square plus sigma y square minus 2wx into sigma y square plus wx square into sigma y square plus 1.2 into wx into sigma y into sigma x into sigma y minus 1.2 wx square into sigma y sigma x into sigma y. This is the rearranged variance function, and this rearranged variance function is calculated by putting wy, by replacing wy with 1 minus wx and putting the value of rxy equal to 0.6, and here by putting this value we have the rearranged variance function, we have the redraft variance function, which comes to this. Now we know that to minimize a function we have to calculate its first order differentiation, and then against this first order differentiation we have to set 0. Now the first order differentiation is to be calculated for the variance function. Now in the rearranged variance function there is only one variable factor, which is wx, because here sigma x is given in the question, so it is constant. Sigma y are also given in the question, so it is also constant. The variable factors in the rearranged variance function is wx. Now we have to differentiate the variance function with respect to wx. Here differentiate both sides with respect to, here we have to differentiate both sides of the variance function. Here we have to differentiate both sides with respect to wx. With respect to wx we have, now we have to differentiate this variance function with respect to wx, because wx is only the variable factors that is associated with the rearranged variance function. Now if we differentiate the variance function with respect to wx, then what will be the answer?